In this presentation, you will learn how a modern demand-controlled hybrid ventilation system and a well-adjusted radiator system can create an excellent indoor climate to minimize energy cost. Hybrid ventilation is the combination between natural ventilation and mechanical ventilation. The politicians in Storfors in Sweden decided to build the most energy-efficient school in Sweden. In cooperation with the University of Karlstad and a group of consultants, the result was a school with energy consumption for heating of 35 kilowatt-hour per square meter in a year. Despite the low average temperature, the indoor temperature is very even over the year without any cooling machine. Because of the low energy costs, the school has employed more teachers. In this picture, you can see the exterior of the well-insulated school building. On the schoolyard, you can see a small house. That house is the connection to the underground supply air culvert, which is the air intake to the entire school. On the roof of the main building, exhaust hoods are visible. Through the hoods, all air is exhausted passively. The core in the hybrid ventilation system is the culvert, which has the air intake in the schoolyard. From the intake, the air continues through the fans that are pressurizing the culvert. From the pressurized parts of the culvert, the air continues to the classrooms through ordinary ventilation ducts. The culvert is located underground, and because of the relatively constant temperature in the ground, the supply air are passively cooled down in the summer and preheated in the winter. This reduces the heating costs dramatically and makes the traditional cooling system unnecessary. You can say that the culvert replaces the heat exchanger as well as the coils. To make the installation system as simple as possible, all the classrooms are oriented around a corridor at each level. The corridor is located straight above the culvert, enabling all piping and ducting to connect straight up from the culvert to every room without unnecessary bends. This enables fans and pumps to deliver the desired flows at very small pressure drops. This minimizes energy losses for distribution. Here is a closer look at the air intake and the first part of the culvert. You can see the light from the air intake and also one of the axial fans and pressurized culvert. Axial fans are used because of the low pressure and the varying airflows. Here you can see some of the installation in the culvert. There are one duct per classroom. They are all placed at comfortable height and they are all out of reach from the pupils, which can't sabotage any adjustments. This picture shows a cross-section of the school. As you can see, the insulation is very thick. The supply air comes through the culvert in which the air temperature is affected by the temperature of the ground. If the internal load is not sufficient to keep desired indoor temperature, the radiator system is activated. Later, the air is exhausted through the corridors and leaves the school passively through a hood on the roof, where no fans are needed. A very important feature of this ventilation system is that it is demand and seasonally controlled. This means that when it's cold outside, the ventilation flow is at a minimum to minimum heat loss. At this point, the radiator system is active and combined with the internal load, the indoor temperature gets comfortable. In the summer, the temperature can reach 30 degrees Celsius. The supply air is cooled passively through the culvert. The flow at this point is very high. This to compensate the indoor temperature, which otherwise gets too high due to internal load. Having a demand-controlled ventilation system is extra important in a school because of the dramatic changes in activities in their different rooms. It is a waste of energy to have full ventilation flow when the classroom is partly or completely empty, which many classrooms actually are several hours each day. This ventilation system has a very high capacity and the ventilation flow is stepwise varying as the need is changing. If needed, the flow can be at full speed in one room and at a minimum in the neighboring. Sequence control is used for ventilation and heating. As seen in the graphs, The supply air temperature is relatively constant over the year compared to the outdoor temperature. This thanks to the variable airflow and the culvert's temperature equalizing effect. To be able to ventilate with highly varying flows and often untempered air, special designed supply air diffusers has been used. This school has diffusers with counterweight that passively adapts the gap in the diffuser. This enables the Coenda effect without the downdrafts regardless the airflow at the moment. A study of the air temperature in the culvert has been made, and one of the results is displayed in the graph in this picture. In the summer, the hot outdoor air is cooled down while passing through the culvert, and in the winter, the opposite. You can actually compare this way of ventilating a building with a termite's nest. They both have natural driving forces that move the air in the construction, and the ground cools the supplied air. The school has a study room called the Green Room. In the room, the pupils can learn about how wind turbines make electricity and how solar panels create hot water. It is important to teach the next generation about sustainability. The energy consumption over 1 year has been measured and displayed in this picture. The consumption is separated in heating, electricity for hot water, electricity for fans and pumps, operating energy for lighting computers, etc., and the produced energy from solar cells. The solar cell produces as much as the pumps, fans, and hot water consumes over a year. We have no energy for cooling thanks to the culvert. Even the heating is very low for being in Sweden, only 35 kilowatt hour per square meter a year. And keep in mind that if we chance the district heating to a geothermal heat pump, the bought energy for heating would be only 10 kilowatt hour per square meter year. In this presentation, you have seen how the great mass of the Earth equalizes the supply air temperature in a culvert. This gives free cooling in summer and preheating in the winter. Combined with variable ventilation flow and well-adjusted radiator system, the sum of the consumed energy becomes very low. Thank you for listening.